All right, these are our LeChatelier notes, and I'm going to go through the example problems. So we have this reaction right here at equilibrium, and question number 1 says, what occurs when Na2SO4 solid is added to the system, increasing the concentration of SO4 to negative? So when this is increased, what is it? Crisis. Not for you, but for the equation it is. It is no longer at equilibrium. It needs to resolve the stress. How does it resolve the stress? There's too much of this, too much of this. I need to get rid of it. How do I get rid of it? Go this way in the reaction, because what will happen when I do that is the amount of this will start to go down, which is the idea. Also though, since this is on the same side of the reaction, this will go down, and this, because it is on the opposite side, they're the arrows, it will begin to increase. So I'll use up this, which is what I wanted to do because there's my crisis. I will also use up this, and I will make more of this, okay? So what occurs? We have a shift to which direction? Left. We could have also said to the reactant side, all right? Let's look at the next one. What occurs when BaO solid is added to the system, increasing the concentration of Ba2+? So what happens? Crisis. I have too much of this. I have too much of this. How do I resolve that? Well, I need to get rid of it. How do I get rid of it? I need to use it up, and I need to shift the reaction this way. Why? When I do, I use this, and I use this over here to make this. Okay, that resolves the crisis. This is the crisis. Okay, so again, it shifts to reactants or to the left. All right, what occurs when BaSO4 solid is added to the system? Crisis, crisis, we were at equilibrium, now we are not. So how do I get rid of a crisis? I have too much. Oh my gosh, I need to get rid of it. How do I get rid of it? Well, I need to go this way. I need to do what? I need to use this up. That resolves the crisis. And when I use this up, see where the arrows are? On the other side, I'm going to make more of this and make more of this. So my shift is to the right or to the product side. All right. Now we're on the next equation. What change will cause the equilibrium to shift to the right? So I want the equilibrium to shift this way. So let's see, what could we do? How could we make it go that way? Well, we could have too much of this, so we need to use it up. That makes the equilibrium shift this way. What else could we do? Well, that's the only thing on that side of the equation. Do you see that? Which means if I would increase on this side, I'm going to have to do the opposite on the other side. So if I decrease this, why would that work? Because the alert is, oh my goodness, this is stressful. I don't have enough of this. How do I make more of it? I go toward it, so I go that way. It would be the same thing for this and the same thing for this. So what could I do? I could increase, here's how we say concentration of HI. I could decrease concentration of H2. I could decrease concentration of I2. And I could decrease energy. Well, how do I do that? I decrease temperature. So here what you should have noticed is this arrow is the divider. So everything on this side, if I increase it, makes the reaction shift this way. And then on the other side, if I decrease everything, it makes it shift not this way, right? Because it's on the opposite side, okay? So we just kind of have to think, if I increase this side to make it shift toward the products, then on the other side of the arrow, I would need to decrease it, okay? All right, let's look at the next one. Which direction will the equilibrium shift when the temperature is increased? We talked about this already. That is represented as energy. So what is the crisis? I have too much. How do I get rid of it? I need to use it up. I shift this way, because when I do, this will start to go down, this will start to go down, this will start to go down, and then this will increase. So I need to shift to left. All right, and then our last one for that equation is increasing the temperature of the system causes the concentration of what to increase. So let's increase our temperature again, right? When we increase temperature, we're going to shift this way, because when I increase temperature, that is going to cause me to use this up as I go this way, right? I'll use this up, I'll use this up, and I'll make more of this. Why does it shift? Because I went to the other side of the arrow. So the HI concentration will go up. All right, and then our last question here for this equation. Which change will cause the equilibrium to shift to the right? So to the right goes this way. How do I make that happen? How do I make the equilibrium shift that way? Well, if I increase this, why? I have too much of it, use it up, go this way. If I increase this, why? Too much of it, use it up, go this way. If I increase this, why? Too much of it, use it up, go this way. Or, here's my arrow, I'm going to do the opposite on this side. If I don't have enough of this, why? I need to make more, so it will also go that way. So I could increase concentration of N2, I could increase concentration of O2. How do I increase kilojoules? Increase temperature. Or, because this one is on the other side of the equation, it does a different thing. I would decrease NO2. All right? And then, which change will cause the equilibrium to shift to the left? So it's going to be the opposite. How do I get the equilibrium to go that way? Well, I could increase this. Why? I have too much, use it up, go this way. Or, now here's the arrow, everything on the other side is going to do the opposite. Why? If I decrease this, I need to make more of it. If I decrease this, I need to make more of it. If I decrease this, I need to make more of it. So, in this case, I would decrease concentration of N2, decrease concentration of O2. Remember, kilojoules, we're going to decrease temperature, or because it's on the other side, it does the opposite. We could increase the concentration of NO2. And there you have all of those from the notes.